everyone, this is Fatemeh. I'll be presenting on facial emotion recognition in virtual reality games. This is our plan for this presentation. I start by introducing emotion recognition and explaining its significance. As you may know, emotion detection does play an important role in human-computer interaction and games user research. But why does it matter? Firstly, because we can understand the level of player engagement to the game. Secondly, we can ensure positive emotional states. And the third reason, which I consider the most important one, is introducing the right level of dynamism to the game. For example, if the player shows a stressful face, the variables relevant to game difficulty can be lowered until the player shows a happy face. Some research has been done on this subject. For example, Young developed a method based on skin conductance and heart rate to classify players' emotions. Dixon used eye movements to recognize players' emotions. Burns used facial expressions to measure gamers' involvement to the game, and the accuracy was 78%. Many previous research utilized entire face images to estimate the human's emotion. Feature points were selected or automatically extracted from the face, and various techniques from nearest neighbor method to convolutional neural network were employed. However, these methods are ineffective to the faces wearing head-mounted displays or HMDs, which occludes the upper part of the face, to be exact, eyes and eyebrows. Our objective in this research is to see whether we can estimate the emotions of players while they wear HMDs. For this purpose, we used SER 2013 dataset consisting of 35,000 face images, and we employed VGG network. It's a classical convolutional neural network architecture used in large-scale image processing. You can see its architecture on the right-hand side of the slide. As you can see, a face expression image is fed into the model. The four convolutional blocks extract high-level features of the image, and the three fully connected layers classify the emotions of the image. We trained the model on the original dataset, and the accuracy was 73%. Then to get our desired dataset, we got the coordinates of eyes and eyebrows in the face images and covered them with a black rectangle, as you can see on the left-hand side of the slide. After that, we trained the same model on the new dataset, and the accuracy was 68%. After that, in order to see the real-world application of our work, we asked 5 participants to play 2 virtual reality games. Their age were between 21 to 27, and 3 of them had played VR games before, but 2 were new to the game. We used iPhone 14 Pro Max to record their faces. First, we asked participants to play Astrobot and after that Paranormal Activity game, while each game session was limited to 20 minutes. After that, participants filled out a questionnaire where they were asked to rate their emotions in the game. This is our result. In terms of emotion detection, participants reported experiencing 3 emotions in Astrobot: happy, neutral, and surprise. And the model successfully detected happy and neutral emotions during the game. This brings paranormal activity, participants reported experiencing four emotions: anger, fear, surprise, and neutral. And the model was able to detect fear, neutral, and surprise emotions accurately. In Astrobot, participants felt happy mostly when all rescued bots appeared and danced before the end of each level. And in paranormal activity game, most participants felt fear two or three times when they walked by an opened window and it suddenly closed, when they went upstairs and the girl NPC character suddenly came downstairs, and when they saw the lady with an axe in her hand on the second floor in the house, which was the scariest scene for all of them. Overall, our experimental findings indicated that CNNs can accurately classify emotions when the eyes and eyebrows are absent. And it's worth mentioning that neutral was the most common emotion in both games. Here are some of the pictures from the video footage show participants' faces, the game scene, and the detected emotion. The obvious limitation of Crane's work is that we didn't capture players' expressions when they moved their heads or turned around while playing. The other limitation is that the model only could detect emotions when players' faces were facing the camera straight, which can be addressed by fine-tuning the model to detect emotions from multiple views. Furthermore, an emotion-based difficulty adjustment solution for uh, VR games is planned to be done based on our work. Thank you for listening, and this is our email. Feel free to ask questions in case of any inquiry.